We are going to work through these notes here, which is all about adding 2 pi. So adding 2 pi to the angle results in a return to the same point on the unit circle. So we can say the following, that sine of 2 pi plus theta is the same as sine of theta. So too, cos of 2 pi plus theta is the same as cos of theta. Now, the reason why this is true is because going 2 pi around the unit circle just takes you back to where you started from. So therefore, you don't even have to consider it. You can just consider the theta value there. Once we see some examples in action, it will make far more sense, and we'll come back to these 2 dot points later. Okay, so here we have sine of 3 pi. So let's try to get it into this form right here. So that is sine of 2 pi plus pi, like that. So as you can see, 2 pi plus pi is the same as 3 pi. And according to this rule here, I can just ignore this 2 pi and just write this as sine of pi. And I can just solve this now. Now, the reason why I can do that is because let's consider what happens when we go 2 pi around our unit circle. So if I go 2 pi around my unit circle, I just get back to where I started from. That's 2 pi there. But now I need to go 1 more pi to get to 3 pi. So that's going to take me here. Do you see how I could have just ignored that 2 pi from the beginning? Because I'm going to get to the same spot. Me going right around my circle is kind of pointless. And this is what this rule is telling me, that if you've got a multiple of 2 pi in your angle, you can just ignore it and just consider what that theta value is going to be. So in this case, it's just what's sine of pi. And we know that that's taking me to this point over here, which is -1 and 0. And sine of pi is telling me that I'm looking at my y value, so it's going to be equal to 0 right there. So that's how we're thinking through these problems. Let's now come to the next one here, which is cos of 5 pi. Now, I can write it not just in terms of 2 pi, but as I said, any multiple of 2. So that means I could write this as cos of 4 pi plus pi, and this is going to be the same as cos of pi. And the reason for that is because consider what happens when you go 4 pi around your circle. That's 2 pi, that's 4 pi. Do you see how I just am back at where I started from? So it doesn't have to be necessarily 2 pi, it can be any multiple. And then I just have to go 1 more pi to get to 5 pi. And now I'm at 5 pi, and do you see how I'm at the same spot, -1, 0? This time it's cos, so I'm looking at my x value, so it's going to be -1 there. But hopefully you can see that it really doesn't matter how many times we go around, as long as you end up at the same spot, it really doesn't matter. Okay, let's go through a few more examples here. What about cos of 8 pi? Well, you might be thinking to yourself, well, 8 pi, if we think about this, and I might even have to zoom in here, I'm going once around to get to 2 pi. I'm going twice around to get to 4 pi. I'm going around again to get to 6 pi. And then I'm going around again to get to 8 pi. So in other words, if I've got an even number there, I know that I'm just going to end up where I began, at 1, 0. If you wanted to, you could write this like this. You could say that it's 6 pi plus 2 pi is equal to cos of 2 pi. And you know that cos of 2 pi is just equal to 1. Or you could just say, well, because it's an even number, I know that I'm just going to end up back exactly where I started from. So too over here, it's an even number again. It's sine of 32 pi. So I know that I'm just going to go around and around and around until I end up back to where I started from. Now, it's sine this time. So that means I'm considering my y value, so it's going to be 0. But hopefully you can see there just how this is working intuitively. All right, let's keep on moving. So here we have sine of 5 pi on 2. So again, we're going to try to break it up as we have done previously. I can break this up into 4 pi on 2 plus pi on 2, because that's the same as sine of 2 pi plus pi on 2. And I know that when I'm in this case, I can just consider sine of pi on 2, and that just means I'm going up here to this point right there. And I know that sine of pi on 2 is just going to be 1, because this point right here is 0, 1. We could come here. Now, how can I break this up? Well, what if I broke it up like this? What if I went cos of 8 pi on 2 minus pi on 2? That's going to be cos of 4 pi minus pi on 2. And this 4 pi is just going around, 1, it's just going around twice, isn't it? So I'm just ending up there. And then once I'm there, it's saying, go back pi on 2. Go back there. So I'm just ending up, and let's see if I can do that a bit nicer. I'm just going back here to that point there. So let me write this out. This is just cos of negative pi on 2. And I know that cos of negative pi on 2, this point right here is just going to be 0, negative 1. Cos is after my x, so it's just going to be 0. So you can think about it in terms of negatives as well. That's acceptable. What if I was given sine of negative 7 pi? Well, in this case, what I'm going to do is say, well, this is negative 6 pi minus pi. So that just means I'm going around my circle a bunch of times. I'm going backwards around my circle, but that doesn't matter because I'm still going to end up back here because it's an even number. And then I'm going there. Remember, I'm going clockwise because it's negative. So this is going to be negative 1 and 0. It's after my sign, so it's after the y value. So it's just going to be sine of negative pi, which is just 0. And then last but not least here, again, how could we break this up? Again, it's a negatives, which makes it a little bit more complicated. We could write this as negative 20 pi on 2. Oops. Minus pi, plus pi on 2, rather. Plus pi on 2. Because that would work, and that means I would get sine of negative 10 pi, which is just going around my circle a bunch of times until I end up where I started from. Then I'm going to plus pi on 2. Hopefully I don't run out of room here. So this is going to be sine of pi on 2, which is going to be equal to, or sine of pi on 2 is just up here. This is the point 1, 0, or sorry, 0, 1 rather. 0, 1, it's going to be 1. So that's a way to think about these questions. If we go back up to the very top, there was 2 interesting sentences there, which says, if an angle is an odd multiple of pi on 2, then its sine is either 1 or negative 1, and its cosine is 0. And so too, if an angle is an even multiple of pi on 2, then the sine is 0, and the cosine is either 1 or negative 1. So if we think about what this means for a second, if we come down to something like this, this is clearly an odd one, isn't it? I'm clearly odd. It's an odd multiple because 5 is an odd number. And you can immediately look at this and say, well, sine of 5 pi on 2, I'm either going to be here or here. Because if it's pi on 2, I'm either here or here. And because I'm sine, I know that it's either going to be positive 1 or negative 1. And that's what it's saying here. So which one was it? Oh, this one. So the sine is either 1 or negative 1 because you're either up here or down there. If an angle is an even multiple, so an even multiple could be, like for instance this, you might say, well, what about this? Well, this is 6 pi on 2, right? 6 pi on 2, which is the same as 3 pi. So 6 is an even number, so this is an even multiple. And as it says, then the sine is 0. And we know that this is the case because sine of 3 pi, well, if it's that, if it's 3 pi or 8 pi or something like that, I'm either on here or here. And if it's a sine, I know that it's going to be 0 because I'm never 1 or negative 1 when I'm here. So you can think through these 2 points, and as you're going through more examples, you'll be able to answer them very quickly just by using these 2 bits of logic as you're going through them, especially in these early days when you're only really considering whether it's 0, 1, or negative 1. Use these 2 points to really help you out. Hopefully all that made sense. An interesting new idea that you have to get under your belts.